Hello everyone, I am Jerry Joseph and I am here to present the Assessment 5 of ENGG955 Research Results. Welcome to my talk, Optimization of Welding Temperature. So, what is dissimilar metal welding? Welding is nothing but the process of joining two metals by melting them using heat and placing them together and cooling them. But it is different from DNW because it uses two chemically and mechanically distinct metals. But every metals cannot be welded together. They should be having a comparable expansion coefficient as well as the melting point. Why DNW? It is one of the simplest methods to make a leak-proof joint. As you know, for an equipment, the different location will be having different necessity of properties, and using a low cost we can build a superior quality weld. DMW are having an increased demand in industrial applications, but when a weld fails, it needs both time and money in order for the maintenance of such a disaster. As well as consider a power plant. If the power plant, a critical equipment fail in a power plant, it can cost up to almost $1 lakh per day. As well as in the extreme cases, the explosion may cause severe casualties. The material we are going to study are AISI. It's a high-strength austenitic steel which is used up to 1000 degrees Celsius. And the other one is 2.25 chromium molybdenum steel. It's a creep-resistant alloy steel which can be used up to 600 degrees Celsius. The welding method can be categorized into two: the solid-state welding and the fusion welding. Consider the friction welding. The temperature does not exceed the solder's limit, and it is good against the heating corrosion, but it can create residual stresses. But whereas the fusion welding, it does not limit the shape of the welding, and there is no need for applying pressure. It is heated up to the melting point. But one of the major problems is the carbon migration. Due to the difference in concentration of the alloying elements, the carbon migrates from the low concentration region to the high concentration region, and this creates a decarbonized zone as well as a carbon-rich zone. The decarbonized zone, which is usually soft, it means it is having low strength and the joint may fail. But whereas the carbon-rich zone is having high carbide contents, which leads to the high hardness as well as brittleness. It can be seen that both of these are occurring in the heat affected zone of the base metals. To reduce this, we can use a suitable filler material. It can reduce the concentration difference. A high carbon filler can improve the longevity, whereas a low carbon filler can reduce the stress accumulation. But note that the thermal expansion coefficient should be between those two of the base materials. The major modes of failures are the creep failure, hydrogen assisted cracking, as well as the failure under tensile loads. The creep failure is nothing but the growth of micro cracks and leading into the failure. It is due to subjecting into multiple cycles, whereas the hydrogen assisted cracking is mainly due to the acceleration due of presence of hydrogen inside the cracks. The major heat treatment process can reduce these failures, and one is the preheating. It allows the escape of hydrogen gas and reduce the shrinkage stresses in it, whereas the post-welding heat treatment can relieve the stress as well as we can refine the microstructure of that. But these processes are both time consuming as well as costly, since it is different from welding. This leads to the general idea of optimization. Optimization is nothing but finding the most effective method to reduce the defects. It is one of the cost-effective methods. The major factors that can be subjected to the optimization are welding speed, welding atmosphere, cooling rate, welding temperature, as well as the heat treatment. Consider the welding temperature. The carbon migration is directly related to the welding temperature. Increase in temperature can cause high migration rate. Also, due to the difference in expansion coefficient, the differential expansion of metals when cooling down causes the formation of microcracks. A proper temperature is necessary for ensuring proper fusion in the metals. This leads me to a question. What are the effects of welding temperature and what is the suitable welding temperature to obtain a sound weld between AISI 310 stainless steel and 2.25 chromium molybdenum steel? For finding the results, I used gas junction arc welding to join these two metals and created 7 specimens under the different welding temperature conditions ranging from 950 to 1250. The welding temperature can be varied with the use of the voltage and current. For this, I have applied it for the preheatment process because it can reduce the microcracks. But whereas the post-welding treatment process can increase the carbon migration rate, so it is avoided. The specimen is naturally cooled in an inert gas atmosphere so as to prevent further cracking. Then it is subjected to mechanical testings for shear strength, tensile strength, impact strength, and finally hardness using the standard methods. For proper fusion and material property analysis, we are subjecting them to a microstructure analysis using a scanning electron microscope. This study is having such plus points such that it considers most of the aspects of failure mechanisms. That is, the lack of fusion is studied here. Then it is research into the carbon migration, the creep failures, and finally the crack formations. Since it is an experimental design, it doesn't involve any assumptions and also provide a realistic solution. But as we can see here, I have already explained the advantages of using a filler materials, but we are unable to investigate into such a matter. And also, the testings are conducted on room temperature. The service conditions may be different from that. So, as a result, we can say that the temperature control is one of the major factors that affects the quality of a weld. And each temperature is closely related to the modes of failures. And using a optimized temperature, we can create a most suitable and quality weld.